All right, now let's continue in 13.1. There's two other topics I want to just touch on. One of them is the concept of effective annual yield. Sometimes it's really hard to compare various investments. Like if you deposit your money in one place and they compound interest daily, and then you deposit your money in another place and it compounds it less often, like monthly, unless they have the exact same interest rate, it's really hard to tell which one might pay off more. Okay, so I didn't really explain that well, but because you are compounding more frequently, that money's going to grow more rapidly. So you might have a lesser interest rate, but still make just as much or more interest. Okay, so usually you'll see what they call the stated rate or the nominal rate on an account, nominal rate or the stated rate. But then they also will give you a rate that helps you be able to compare various investments, so various accounts. So, and it's called the effective rate or the effective annual yield. So what it does is it kind of converts the nominal rate to what the interest rate would have been, okay, if it were simple interest rather than being compounded a certain number of times. So it's converting an interest rate that involved compounding, a compound interest rate, into what an equivalent simple interest rate would have been for 1 year. Okay, so here's the formula for that. And again, you'll have the formula. You just need to use it. So it uses the very familiar R and N. So R is the interest rate. This one's a little harder. 4.2% would be 0.042. You could take the 4.2 and divide by 100 if you needed to get that. Okay. All right. And then the N, since it said compounded monthly, the N would be 12. So I'm just going to put that in. 1 plus 0.042 divided by 12 in parentheses, raised to the 12th power, and then I'm going to subtract 1 from that. All right, and I just type this in my calculator. This is what it looks like. I do a left parenthesis and then 1 plus 0.042 divided by 12. It will do the division first and then add 1, which it should. Then I'm going to raise that to the 12th power, okay, and then subtract 1. And it'll do the exponent before the subtraction like it's supposed to. All right, when I do that, what I get is about 0.042818,007. You don't have to keep all that accuracy. A lot of times they'll after you convert that back into a percent, you might keep 2 or 3 decimal places, but after you've converted it back to a percent. So to convert to a percent, this would be equal to, move the decimal 2 places to the right, because here we moved it 2 places to the left to go the other way. So we're going to multiply by 100 or move the decimal 2 places to the right, and we see that an interest rate of 4.28, maybe 282, I'll stop there, percent is the effective annual yield, meaning if I had deposited the same money in an account paying simple interest for 1 year at a rate of 4.282%, it would earn the same interest as a compound, money deposited in an account paying 4.2% compound interest and compounding monthly. Okay, so it allows me to compare in different investments, different accounts. All right, now inflation is another topic I just want to touch on. And it also gets at the idea of continuous compounding. Like earlier, our formula that we used back here dealt with when you had a finite number of times the interest was compounded, like twice a year or 4 times a year or 365 times. All right. But there is a formula that determines how much would be in your account if they virtually compounded the interest just continuously, like all the time. It's like n is infinity. And if that's the case, the formula that we use is this one, okay? So we could use it on earlier problems if it were a problem that talked about compounding continuously. We're going to use it on these inflation problems, okay? Because inflation is something that is just constantly fluctuating. Um, let's just go back through the information there about inflation. So, like, what money will buy today is different than what you could buy later. Okay. So usually you could buy more today with $1 than you could buy later for $1. Okay. So money loses value over time. And that increased in the cost of living is called price inflation. Price inflation. So things cost more, or the value of your money is less as time goes on. So it's okay, like if you have a bank account where interest is compounded monthly, that means everything's going along, nothing's happening, and then at the end of a month they calculate your interest, and all of a sudden you have a sudden jump in how much is in your bank account. And then another month goes by and you have another sudden jump in your bank account. So with inflation, that's really not what happens. The price levels, they tend to fluctuate continuously, but gradually over time. So it's more appropriate to use the formula for continuous compounding for this situation. Okay. So inflation is usually expressed as a monthly or as an annually rate of price increases. Okay. And it's estimated by the government agencies. They have a way of calculating this. Okay. And they publish consumer price index figures, which reflect the prices of certain items that a lot of us purchase. Okay. So let's take a look at how this formula could be used to figure out how much a cup of coffee that today might cost you $1.25 might cost in 25 years if the inflation rate were 2%. Okay. If the inflation rate persists at 2% over time. So we're going to use the continuous compounding formula, and we're going to think of the price of the coffee like we would the principal. And then I'm going to explain what E is. Let me erase that for a minute. All right, E is an irrational number. So that's a number that has a decimal equivalent that I can't write down because that decimal goes on forever and never repeats or anything. So the only way I can give you the exact value of E is to use a symbol to denote it. Okay. Kind of like pi. So I'll say E is an irrational number like pi. We know pi is about 3.14, but it's a decimal that keeps on going forever. So we can't really write out the whole entire decimal. Okay, there is an E button on your calculator, so find that. There is an E button on the calculator. You need to find it. So on most calculators, it's usually associated with the LN button. On mine, it's a second function. It's a function right above the button, the LN button. So I have to hit my second function key to get it. All right. And so just like pi is around 3, so is E. E is about 2.72 if I round to the nearest hundred. So it's less than 3. But the important thing to remember, it's not anything like a variable. It's an actual number that has one set value to it. You don't replace E with 2.72. Just use the E button on your calculator, which is still an approximation, but it's better than you rounding it to 2.72. Okay, so the formula says put in the 1.25, then do E raised to the, then it says R, which is 2%. So that's this is 0.02, and then multiplied by the number of years. So 25 years. All right. So when you type this in, I love the way my calculator does it. That 125 and that E, when I select the E, it comes up with the caret key in the left parenthesis for me, which is great because I need to be sure my order of operations is being done like it should. Okay, so you need that 0.02 times 25 to happen before you do E raised to that. So this would do it if you use those parentheses. And you should be trying these. You should wind up with it costing about $2.06. So that $1.25 cup of coffee now is going to cost you $2.06. So hopefully as the prices wind up getting to be more, hopefully our income also is increasing so we can afford to pay these higher prices.